Hi everyone, today we're going to study the parabola with vertex at HK and opens to the left. Let us first define a parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us consider now the parabola with vertex at HK, this is the vertex, and opens to the left. Let us pick one point of the parabola and denote it as P with coordinates xy. The standard equation of this parabola is the square of y minus k on the left side equals negative 4a times the quantity x minus h. Again, we say that the vertex at HK. This a is the distance between vertex and focus or directrix. With regard to the value a, the focus has coordinates h minus a, comma, k. In our graph, this is the focus. For the directrix, the equation is x equals h plus a. This is the directrix. The axis has the equation y equals k. This is the axis. Remember, axis is the line perpendicular to directrix and passing through focus. Now, for the length of latus rectum, this is equal to 4a. This is simply the positive coefficient of the quantity x minus h in the standard equation. Remember, the latus rectum is the chord drawn perpendicular to axis and passing through focus. In our graph here, this is the latus rectum. Now for the endpoints of latus rectum, this will be our formula. These are the two endpoints. The x coordinate is the same, which is h minus a, while the y coordinate is k plus 2a for this point and k minus 2a for this point. Let us see this example. Find the equation of the parabola with focus at 2, 4 and directrix x equals 10. Sketch the graph. For our solution, let us first write the point 2, 4 as the focus, and this is the line x equals 10. We can now draw this parabola here. Given a focus and directrix, we can say that this is a parabola with vertex at HK and opens to the left. Thus, this is our standard equation. Next, we're going to find the vertex and A. Please note that vertex is the midpoint of the horizontal line segment. We denote this as 2a, this is the line segment, connected by the focus and a point of directrix. By analyzing this figure, we can see that from this point, which is the focus, up to the directrix, the value or the length to A equals 8. We can find A by dividing this equation by the coefficient of A, which is 2. So the value of A is 4. And from here, we can now find the vertex, and that is the point 64. Now let us substitute the value of A equals 4 and vertex 64 to the equation. So we have now the square of y minus k now becomes y minus 4 equals this negative 4a now becomes negative 4 times 4. This x minus h now x minus 6. Simplifying further, let us multiply this negative 4 times 4. So we have now negative 16. This is the equation that we are looking for. Let us write again the given of the problem, and that is the focus at 2, 4 and the directrix with equation x equals 10. A while ago, we were able to write the vertex at 6, 4. Now, let us find the axis, and the formula is y equals k. Remember, this k is the y coordinate of the focus. So we can write now y equals 4. And this is now the axis. Next is the length of latus rectum, and we write this as 16. We simply copied the positive coefficient of this x minus 6, and this is the answer here. And the endpoints of latus rectum, we will have this formula h minus a for the x coordinate and k plus or minus 2a for the y coordinate. This is our latus rectum here in the figure. A while ago, we solved for a, and that is equal to 4. It means to say the endpoints of latus rectum are 2, 12. This is the point. The other endpoint is 2, negative 4. This is that point. This is our final answer. I hope you learned something from this video. See you again next time.